Hello, welcome, and thank you for tuning in to today's live webinar series for part 3 of our 3-part pneumatic pump live webinars. I'm Joe Revelle. I'm a sales and technical rep here at Solence.
Susan Lloyd, technical sales and support as well.
So I mentioned that this is part 3 of our 3-part series. So just a quick summary. Part 1, we looked at choosing the right pneumatic pumps for your application. So we talked about the different options we have available, highlighting key features, and looking at deployment options. Webinar 2, we focused on pump operations, so taking all of that information and showing you how to actually operate them. And this one now will be focusing on all of that information, but bringing it forward in terms of troubleshooting and maintenance that are involved with the different options. So for now, we'll get started and show you how the presentation will go.
So now that you have the equipment, we've created a couple of checklists for each of the components. So you're going to have an air source, you're going to have the controller and the pumps, and this is lists for you to use in the field. At the end of the presentation, we're going to have a wish list of if these checklists don't work for you in the field and you've got other issues, what we need from you to work with you on a case-by-case basis to get a solution.
Okay, so for those of you who had the opportunity to tune into the first 2 webinars, this might be a bit of a review, but we also wanted to include it for those that might just be tuning in for the first time. So I'm just going to go through the various components quickly and show you how we have it broken down into 3 categories if you want to look at it that way. So when we do jump into the troubleshooting, they'll be split up into these 3 that I'm about to show you. So the first, we have everything down well. So on your screen, you can see an expanded view of the pump. So that includes either the double valve pump or a bladder pump, the tubing connections, and then the tubing running up to the surface. The next part of a pneumatic setup, and what makes it pneumatic, is that it needs an air source. So everything in terms of operation functions off of either drive gas, so it's either a portable compressor like you can see circled on the screen, or maybe you've got a larger 2-stage compressor if you're sampling at deeper depths, or you could be using a portable air cylinder. So all of those options fall into the air source, and for this particular presentation, we'll be focusing on our portable compressor, just because that's the piece we manufacture. Obviously, troubleshooting outside of that relates to the compressor or the air tank that you're using. And then the third piece that completes the setup is the electronic control unit. So this is what's used to set your drive times, your vent times. It regulates the flow from the compressor down into the tubing, into the pump body. So all 3 of those interact together to make a complete pneumatic setup. So you can see on the screen we have some yellow arrows that indicates direction of flow of the air from the compressor to the control unit. It's regulated there, and through the drive times, which you'll see later in the presentation of how to set those up, it's pushed down through the tubing into the pump body, and then the sample comes up to the surface. So on the screen you can see a blue arrow that represents a sample coming up out of the sample line into the sample bottle. So that gives you a real quick overview of the various components and how they all interact together to make up a complete pneumatic setup. Now we've put together a video which goes through each of these components, so we'll switch over to that.
The air source video, the selection is going to be based on your applications, regulations, guidelines, and portability. As Joe mentioned, we're going to be looking at the 12-volt compressor. So what we're going to be doing here is a 360 turn and looking at some of the features and also some of the maintenance tips. Got 100 feet of lift. It's good for shallow applications, 21 pounds, and it is light and portable. What we're looking at right now is the ball valve. You turn this on once the tank has been fully charged, and later on you will see us using the pin at the back to release the pressure on the tank. Here's the alligator clips. This is used with your vehicle. Please keep it running, otherwise you're going to drain your battery on your vehicle. Now the next side is we just wanted to comment about the auto shut off is normal if the compressor gets too hot. It's thermally protected, and it will also shut off at 125 psi, and there's a gauge there, and it will turn on at 90 psi. We're going to go to another video clip, and that's going to be showing maintenance on draining the unit. So what we didn't show you earlier in the 360 view was the drain. So you do not drain you do not open the drain valve until all the air in the compressor has been released. So it's using the pin at the back of the ball valve, but also the pressure gauge should show 0. We recommend that you drain every day or every 20 hours, and Joe will be soon explaining the section on the controller. It's going to be the next video clip.
Okay, thanks, Susan. So yeah, moving up to the controller, which you can see on the screen here now. The main thing to keep in mind in terms of operation in the field is keeping that control box up above the high point of the well. So you can see here it's up above, so that's not introducing a downward flow or a backwards flow from the tubing back into the control unit. So that keeps all the moisture out. And we also have an external filter with a water trap that's in line. So this is something that you can use for maintenance. If you don't have one, we do have these available, so you can add it in, and that just keeps any moisture out. If for whatever reason you do get moisture into the control box, here's a quick tip of how to resolve that. So we can go in, create a user setting, and set a drive time of 10 seconds and a vent of 2. We'd repeat that process for 10 minutes, and that just helps dry everything out. So you can see here, pretty simple in terms of a couple buttons to set it up. If you're uncertain of how to use the control box, on the inside part of the lid, we do have a quick start guide. So that's handy if you're first time user of the box. You can see how to actually set it. So we go in here, save. The PSI on the screen is just a reference. The actual pressure is set through the regulator, so turning at the bottom. And now we've got it saved. We can go in, select that, and like I said, run that for 10 minutes and it will dry everything out for you. Now, another piece of maintenance would be batteries. So here the battery cover just twists off, no tools. 4 AA batteries, easily accessible. With this, we do recommend replacing at 60%, or obviously if you're below that, you want to replace them. If for whatever reason you don't have replacement batteries on site, you can still operate the pump in manual mode without the batteries. So instead of having the timer do it automatically for you, you would hold down the silver button in the upper right corner, which you'll see here momentarily. So you hold it down for drive, to be 1, 2, 3, and release for vent. This is also handy if you're on a site that doesn't allow battery operated equipment, so you're still able to run and collect your samples without the batteries installed.
Okay, this section has some very quick video tips, so I just want to be, we're going to go through them quickly and then do a review. So we recommend that you use a safety line on the heavier 8-pound pumps, whether it's the double valve pump or the bladder pump. And typically what we would suggest is if you're looking for leaks, you would use a 5-gallon bucket. In this case, we're seeing a leak at the tubing connection to the pump, and we're going to go through a couple of videos on how to resolve this potential issue. So the first example that we have here is either a double valve pump or a bladder pump. It's got the compression fittings. There's the adapter for the 1/4-inch tubing. And what you see being pointed out right now is the tubing inserts. We have 2 different tubing sizes for the drive and the sample. So we're going to do an example with 3/8, but there's the wrench for the smaller compression fitting, and there's the wrench for the larger compression fitting. All of these instructions are on our operating instructions. So you would put the plate tubing insert into the tubing so it does not get crushed. The ferrules are already in the compression fitting right there. It's inserted in, and you would tighten this finger tight. Now, to make sure you don't get those bubbles that you saw in the previous video, we're going to mark it here, and it's just a wax pencil or a fine china pencil, and then you're going to take the wrench, and it's going to be 1 1/4 turns. So this is going to make sure that the tubing is secure enough and tight enough that you don't get those leaks that you saw in the last video. Okay, 1 turn, and we'll just finish that 1/4 turn. There we go. That should be secure enough, and of course you would do the same thing with the second compression fitting as well. The next example will be the 5/8 double valve pump, and this has our barb fittings. So we're going to show you how to install these so you don't get any leaks at the tubing pump connection. It's just going to cut that off. Maybe it's skip bonded, or actually I guess get the label off. And using some environmentally friendly lubricant, water. And that's going to help lubricate the tubing so it can go on those barbs. It's difficult to see in this video, but the barbs are, there's quite a few of them there. So it doesn't, you really do need to push that on. And a tip that we have for people is to, there we go, use some sandpaper. Both of those are installed, it's nice and secure. And so just going to give a little tug there. Just going to let you know that the next video is pretty quick, and I'm just going to let you know what it's going to be, and that's going to be the leak at the bottom of the pump, and this could be because of a check ball. So the next video clip is going to be the technician looking for something called bathtub rings. This is mineral deposits on the check balls that don't allow it to seat properly. And we'll discuss this a little further later. Now, the next thing that we wanted to show you is here's a sample line, and this is when sample line in a bucket, and this is showing the air before the water sample coming up. Aha, this is what we don't always like to see, the vigorous bubbles. This is an example of when you have perhaps a double valve pump and the drive is too long and the air goes through the pump and up the sample line. So we just wanted to show you that as an example. Because we went through these video clips so quickly, we're just going to go through a review of what we just discussed. So this is the pump system checked. We're looking for leaks. And the first thing that we're going to be looking for a leak is, am I hearing any noises that aren't the normal control unit noises? And if you are, then you investigate further. And those are the three components that you would check. And the first one would be the pump connections. And we showed you how to tighten and reconnect. Now, what we didn't go into detail was checking the O-rings. So it could be O-rings that need to be replaced, check balls that need to be replaced, bladders that need to be replaced. We have detailed instructions and parts for all of our pumps. And then the third thing that we didn't do in a demonstration and where you could potentially have a leak is you could have a damaged tubing, and that may need to be replaced. So what Joe is going to do next is he's going to do a review on all three components, and then we'll just keep on going.
So as Susan mentioned, I just want to go through the various components and do a review of the maintenance that we've touched on, and maybe introduce a couple other pieces as well. So the first one would be the compressor. We showed how to replace the fuse in the video, so that's something that would be over long-term use, or if the compressor isn't turning on, part of the troubleshooting. We discussed draining it daily or every 20 hours of operation. So as part of your maintenance or maybe your workflow, when you're done using the compressor and you're putting it away on the shelf, just drain all the air out, relieve that pressure, just so you don't have that pressure vessel sitting on a shelf somewhere. So that's definitely something to do in terms of storage. And then obviously the battery source that you're using, making sure that that's of sufficient voltage and charging if need be. The next, we looked at the pump control unit, so replacing the batteries. As with any piece of battery operated equipment, you will need to replace those over time. So for AA batteries, if you don't have those replacements, we did touch on using that manual override button. So you're still able to collect your samples. Let's say you've got one more well and you're hours away from any batteries, you're still able to get that sample up and out and not spend another day driving back out into the field. Using the supply and drive lines that come with the control box, that's not really something to do with maintenance. Unless you lose it, then you want to maintain, purchase those again. We've created those for optimal use with the equipment, so you want to be using the actual supplied drive lines and supply lines. They're pressure rated to what the control box can output, so use those. We talked about using the filters, so part of your maintenance is maybe draining that water trap if you do have moisture in there. We talked about how to resolve if moisture does make its way in. Not really, again, maintenance, but that's more of the troubleshooting side, but that might just be something you do by routine as part of your maintenance checks. And in terms of storage, take the batteries out just so you don't have batteries sitting in a piece of equipment that isn't being used on the shelf. And then the pump itself. So in terms of maintenance, you want to do those site visits, especially if you've got dedicated pumps that have been down well for a number of years. You might want to pull them up, do a visual inspection, check the O-rings, check the check balls, replace bladders if it is a bladder pump. So doing that visual inspection, obviously you're going to know if something's wrong. You're going to do an investigation at that point, but you might want to do just some preventative maintenance to help minimize potential troubleshooting down the road. And I touched on the bladders, so that's important. With the dedicated, over time the bladder could become weakened and you need to replace that. And with a portable setup, just replacing those bladders between sites, not maintenance, but that's part of your decom. But it still gets you into the thought process of what needs to be done and what pieces could be part of your maintenance with everything. Now, this section we have here, we mentioned at the beginning, we would give a summary. If all else fails, we'll be the ones hearing about it. So we put together a list of things. You've gone through the troubleshooting, you've done your preventative maintenance, but maybe you're still having issues or you're not getting what you typically obtain from previous site visits. So this list here is just meant to give you an idea of the types of questions we'll ask, or any distributors that are watching, the types of questions you would want to ask your customer to help resolve the issue. So the first obviously would be the symptom. We want to know what is the reason you're calling us, other than to find out who's in the playoffs, what the weather's like, anything like that. So we want to know the symptom. Are you not getting a sample? You're not getting sufficient flow? Or are you seeing bubbles in the tubing? We'll want to know what's going on. Pump type. So we've discussed the different options in the previous webinars. So we want to know, is it a double valve pump? Is it a bladder pump? And maybe Susan, why would we want to know that?
Because they operate differently, and yeah, so they just operate differently. We need to know that information. Is very important. Exactly.
So the setup, we're looking at dedicated or portable, and that really just gives us an idea of what other pieces of equipment are part of the setup. So that all blends into the operating principles. So we'll want to know, do you have a dedicated well cap? Are you using a different dedicated well cap? Are you using a portable reel? That's all important information of helping determine the typical setup.
The one thing I'd like to, a common question that we get is regarding portable reels. If you don't need that extra tubing, don't leave it on the reel. The reason being is that the sample needs to go through so much of the tubing line, and it does take a lot longer to get your sample, and you're using a lot more air. So if you don't need it, take it off.
Exactly. So I just put two up on the screen. So pump intake depth and static water level. So we'll want to know where the pump's situated in the well, and also the static level. So we'll know, one, how much water is above, and two, depending on what type of pump you're using, looking at the operating principles, it either relates to the static depth for the double valve pumps or the pump intake depth, so distance below ground surface for the bladder pump. So that will tell us where you're situated within the well and how much water is actually there. And kind of tied to that is knowing what pump settings you're using in the control unit. So your drive times, vent times, and pressure. So all of that's taken into account when looking at the operating principles. We keep drawing back to that, but that's really the guide of what needs to be set in order to get the sample up to the surface.
And often when you're having an issue getting a sample, it's a question of optimizing the drive and vent times. The webinar 2 discussed that briefly. There's a nice groundwater sampling document, and there's a section in the controller manual about optimization, just to give you a little help there.
Yeah, exactly. And you don't want to have, like we saw in the video with the vigorous bubbles on the right-hand side. That comes into your pump control settings. So there we had a drive line that was too long. We were just voiding the whole system and just introducing that drive gas in. Now, well diameter, we'll want to know that as well. So that just tells us, is there actually enough water in the complete setup to actually get up to the surface?
And sometimes there isn't enough water, or sometimes the recharge is so slow that, you know, you're only able to get a sample maybe once every 6 months.
Exactly. And then any modifications. So we're making the assumption that everything you're using in your setup is as we would have sold it originally. So no external pieces or any modifications. So if there are, we'll want to know about that, because then that will help factor into what could potentially be causing the issue.
Other modifications would be different tubing sizes. If tubings run along the surface for a long distance, there's lots of modifications we've seen over the years. So those are important in helping troubleshoot what issues you may be having with the pneumatic pumps.
And it's always something we like to see modifications too, because then it's always neat to see, we know kind of what we provide, but obviously in the field you often have to improvise or make something up. So we always love seeing any sort of modifications, because it could be something that could benefit the masses, right? Or it's just neat to see how our equipment's actually being used.
Yeah, it is.
Now, as always, keep an eye out for upcoming webinars, product releases. So you can see on the screen our Facebook logo, Twitter, all the social media platforms. We're releasing information, case studies, all real useful information that we find useful, and I'm sure everybody else does as well. So if you haven't done so already, make sure you like the socials, keep an eye on our website. If you have any questions, you can give us a call. A lot of you have our individual emails. If not, our main general inbox is instruments@solents.com. So send in any questions you have there. Feedback about this webinar, any of the previous webinars, or maybe you have some exciting topics that you think we should highlight in a similar type of webinar, let us know, and then we'll take those into consideration as well. So as always, just want to say thank you for tuning in for this on behalf of myself and Susan over here.
And as I tell you when I'm on the phone all the time, have a good field day.
Okay, thank you. Until next time, take care.
Bye.